So I'm Jason. You may have noticed that this slide title is not the slides that you guys showed up for. That's not a mistake. Our projects got, or our talks got kind of merged today. So what's going to happen is for people who are just getting started with Python and using Python on EVM, I'm going to show you a QR code for these slides. And you'll be able to come back later, or on your time now, to get started up, because Nick's going to start his talk in just a few moments, and they'll assume that you know the basics of how to get connected with Python. So these are from my slides at DevCon last year, and they are just to get you started. So here's a QR code for people who are interested in this sort of intro level slides for the Python. Just random shout out for Constantinople coming up in a couple weeks. If you're not aware yet, some intricacies of Create 2 means that you can't assume dead contracts stay dead if they've been deployed after Constantinople. So check it out if that was news to you. That's all I have for today, and it's on to Nick for the rest. I'll be walking around. If people have questions, just raise your hand and I'll come help you out.
What's the name of your blog post?
Oh, Defend Against Wild Magic.
Defend Against Wild Magic on Medium. Google it and you'll find it. All right, we're going to do some package management. This isn't really like a code long session because time is short, but the code I'll be going through is here. And so you can go steal it and play with it locally. All right, cool. Icebreaker. Hands up if you've ever used a package manager before in any operating system or any language. All right, cool. All right, how about this? Hands up if you're a developer and you've never used a package manager. All right, cool. So yeah, this talk isn't to convince you we need a package manager in Ethereum, because those hands or lack of hands should be enough. If you need convincing, in the repo I just linked, there's a good blog by Nick from Truffle. Okay, so the first rule of EthPM is only install packages from trusted registries. This is because in EthPM, anybody can deploy their own package registry, which means they can publish malicious packages to their package registry. So if you don't trust whoever's in control of the package registry you're interacting with, you could be dealing with malicious code. So it's just something to be mindful of. And just because you find a package that's available on Reddit doesn't mean you should interact with it unless you trust the registry's owner. So yeah, recently we have this EthPM Explorer, or Explorer for EthPM, which basically helps you interact with on-chain registries. And we have a directory here, and this just came out last week, so it's pretty scarce. But here are some registries you can go explore and play with, and use their packages. If you create your own registry and want to be listed here, just send me a link in the Gitter channel, and I'll include you. Okay, so today's storyline, more or less, is Grandma has gone surfing and a shark bit off her arm. But luckily, Grandma's part of a financial savings co-op that provides funding for prosthetic arms, but only if your arm's been bitten off by a shark. So she needs approval from a doctor to confirm that it was indeed a shark that bit off her arm. Basically, we're going to deploy multi-sig. The co-op will fund it and approve a transaction to give Grandma funds, and then the doctor will approve that it was a shark that bit off her arm, and then Grandma will be able to purchase a nice new arm. So these are some words I'll be using today. Registry. It's basically a smart contract that lives on chain, and it hosts all the data for your packages. A package is basically a collection of package releases, but what ties them all together is their package names. So you'd have a wallet package or a multi-sig package or any kind of package you want. A release or a version is 1.0.0, 1.0.1, and it's composed of a package name, a version. In EthPM, we don't really care what versioning you use, but some semantic versioning is suggested. And the third component is a content address URI. So this is your IPFS or Swarm URI. We also support GitHub blobs. And then a manifest is the JSON file that represents a release. So it's basically just a big JSON object that has all the contract assets and the package name, version, and not the URI. But the URI, like what is resolved at the URI, is a JSON manifest. All right, so let's start with a little setup. So we're using some libraries today, web3.py, this local library, which is just some constants. We'll also be using PyEthPM and EthUtils, and these are all open source libraries. You can go check them out and contribute. So we're just importing some good things to use. In this next slide, we're setting up some middleware. So Web3 provides this nice middleware to automatically sign and send your transactions instead of doing that manually, more or less. So on this line, we use our private key to construct the middleware. Then we add it to our middleware onion. We set the default account. And then this last line is like a temporary flag since the package management API is still unstable and might change. Just for security, you have to enable the package management API. Cool. So yeah, Web3 more or less is the layer or what sits between you as a dev or your dApp and the chain. In the same way, Web3.pm is what sits between you, the dev or a dApp, and an on-chain registry, and just provide some good functions to make it convenient to interact with your on-chain registry. And as you can see, it's just a Python class. And so web3.pm, like, let's check out what the registry is, and it says PM object has no registry, and that's because, again, there is no like central package registry that should be used in EthPM. So we don't ship with a default registry. You should be like cognizant of, shout out, of which registry you're attached to, and make sure these are always trusted registries. So here on this next line, we're setting our registry to snakecharmers.eth. This is a package registry that like I deployed and I control. So if you trust me, you can trust my packages. If you don't trust me, you shouldn't use it. Here, this is, all right, so this is a Coven registry. It has a fair amount of packages, all the dApp hub, another shout out packages, some of the spec packages, ENS, DI, registries, some other things. Here's the Snake Charmers registry. It's on the mainnet, and these are the packages we have. This multi-sig package is what we're going to be using today. This is the Gnosis multi-sig contracts that I packaged up. You can see we have the version and the URI here. The package name is multi-sig. Let's go check it out. And this is basically like just a pretty view of the JSON file. Like here is this is the raw manifest, the IPFS that's stored on IPFS. Just all the different fields for a manifest. We have the contracts are available there. The contract types are here, which is basically like ABI bytecodes, compiler data, etc. So that's the package we're going to be playing with today. Okay, so yeah, so we've set our registry to Snake Charmers and like use ENS again, like always use ENS. But you can see now we have set our registry, and this is the Snake Charmers address. Okay, so now we're deploying our save grandma multisig. The package is the one we'll be using today is a Python class. You need a manifest and a Web3 instance to instantiate your package. It provides some nice helper functions, and it's also chain agnostic, so it doesn't matter what chain your registry lives on. The package can interact with any chain, so you can have your packages live on Ropsten and store mainnet deployments on it. So, okay, so on this line, we're going to get our multisig package from the Snake Charmers registry, and you can see it's returned this package class, which is a Python class again, multisig 1.0.1, which is that manifest I just showed you in the Explorer. And here, this is just to confirm that we have what we want. This is line 8 is just getting the release data from the registry. And you can see these are like the unique identifiers for the package we're working with. And then for our package instance here, the URI attribute is the same IPFS hash as is stored on chain. Okay, so to deploy a new instance, we need a factory, and we have our multi-sig package instance. And to get your multi-sig factory, you just call get contract factory and pass in the contract type. Cool, and so everything's kind of on the mainnet here, and I don't want to deploy contracts right now because it's iffy. So I've deployed this contract earlier today, but basically, like, it's a one-line deploy once you have your contract factory. But again, I'm not going to deploy it. Just use this hash to look up the transaction receipt. Cool. So for all intents and purposes, we have just deployed a new multi-sig instance that we're going to use to save grandma. Cool. So now we've deployed this new instance using the Gnosis multi-sig package. But now we're going to create a new package which will contain this deployment. And here we'll be using a builder tool that's from EthPM, and basically it can either start from scratch and compose a new manifest, or it can extend an existing manifest. Also handles like pinning to IPFS and disk writing, or writing to disk. Again, like this builder tool is a dev tool. It's really meant for other tools to be built on top of it, so it's not really like sexy and streamlined for like the dev experience. But if you need a hackathon project, build something to make it much nicer. So on this first line, we're piping in the old manifest that we started with. Second line, we're updating the version to 1.0.2. This chunk, we're adding the deployment. So these are the different fields that go into a deployment to identify the on-chain deployment. And here we're using the validate function to make sure that the resultant manifest conforms to the JSON schema, the EthPM specification. And then this last line, we're pinning it to IPFS. And we're using the Infura backend here, but you can use the local IPFS or any other gateway if you want. Cool, so our new package that we've just created has been pinned to IPFS, and this is its hash. And now we're creating, this is the content address URI that will be sent to the on-chain registry to identify our package. And really quick, I'm going to grab the ENS package from the registry while we're still connected to the trusted Snake Charmers registry, because we're going to use the ENS package in a second. Cool. So this doctor has just deployed a new multi-sig, and he wants to publish his package, but he can't publish it to the Snake Charmers registry because he doesn't own it. So he's going to deploy a new registry and then publish the package to his newly deployed registry. But again, like before, mainnet is iffy, and I'm not going to deploy a new registry, but I did one earlier today, and this is its address. And like, we can look up this package registry that was deployed earlier today, and you can see it's just an empty registry. Cool. So right now this Web3 instance is connected to the Snake Charmers registry, but we want to update that. And this is a one-liner to deploy a Viper instance of the registry contract and set it to the active registry on your PM object. So it's a very easy to create your own on-chain registry, but we're just going to set it to the one here. Just cool. This is like the active registry for our Web3 PM instance. All right, and so like just to harp a little bit more on it, everyone should be using ENS. Like passing it around contract addresses is just like not good at all, and we have enough problems in this ecosystem with UX. We shouldn't make it hard on ourselves. So if you remember, I grabbed the ENS package just a couple steps ago, and what we're going to do is we're going to tie this newly deployed registry to an ENS name. I already own this ENS name, so we're not going to stay here for 3 days and wait for the contract to expire or the auction to expire. But within this ENS package, everything you need to bid, reveal, finalize, etc. on an ENS name is available. So we're going to get our resolver instance. This is the instance on the mainnet. Our domain for our doctor is Dr. Mantis Toboggan, and this is just to set the name hash. And so right now, Dr. Mantis Toboggan is set to this address, which is OX8F. But we're going to update it to our newly deployed registry address. So, all right, some things. All right, so let's see. Yeah, so again, we're using the resolver instance on the mainnet. We just grabbed this from the ENS package. If you didn't notice, I didn't copy any contract address. I didn't copy any source code or bytecode or ABI. It was just very simple to grab, and now I'm interacting with the ENS on the mainnet. Hopefully this transaction processes quickly, but we'll see. Yeah, I guess. Cool. All right, there we go. So the transaction is processed. And just to like verify that everything worked, let's look up drmantistoboggan.eth on our Explorer, and it should resolve to the same, there you go. It's the same registry that we just deployed. So now we have a newly deployed registry tied to an ENS name in only a couple lines. All right, so now we have this new registry. Let's publish our save grandma package to our registry so it's available. If you remember, I created the content address URI 4 or 5 slides ago, and this is a Web3 PM method to easily release your package to your actively set registry, which again is the doctor registry. This is a transaction, so it'll take a second. The only in EthPM, we don't care what versioning you use, but the only rule is that once a package version has been released to a registry, you can't release the same version twice. This is, you know, like if you release 1.0.0 and then change it with a malicious version, that's poor experience for whoever loses their money. So, yeah, once you release a package version, it's the only version that's allowed on the registry forever. You can delete it, but then you won't be able to re-release a same or a different version of the same package. This is taking a little but it should go soon, hopefully. And if everything works, so we're back to Explorer, and this is the registry, and hopefully very soon this will show this newly created package. Yeah, again, like it's very simple to deploy your own registry on chain. We have 2 reference implementations. One's in Viper and one's in Solidity. They're both ERC compliant, so the Solidity one is a little more full-featured, but it's also much larger and more expensive to deploy. The Viper one's toned down and simple and just very, very easy. The Viper default registry doesn't support deleting packages, but there's another version you can that's available if you want to release it. This is taking longer than expected, but sooner or later it'll go through. Hey, no, I think it timed out. All right, yeah, it timed out, but I mean, it'll come through soon, I hope. But let's just move on, and then we'll catch up with it in a second. Oh, okay. Come on now. Well, yeah. I mean, this is what happens when you use mainnet in a live code demo. And I don't have anything to fill this time, so we're just gonna skip this step. But It's just another helper function to interact with your on-chain registry. All right, cool. So now we've completed all these steps. We've deployed a new multisig. We've packaged up our deployment. We've deployed a new package registry, tied it to ENS, and we've published our new package to our registry, all without like any copy and pasting, all in like a couple lines, or not that many lines of code. So now let's start interacting with this new package, which contains our new deployment. And so now it's up to the co-op to fund and approve this Save Grandma deployment. So this is a new Web3 instance. It's connected to the mainnet, but it's already been gone through the automatic sign and send transaction middleware setup we started with, but with a different private key. So it's essentially just like a different party's Web3 instance. And again, the PM module doesn't ship with a default registry, so we have to set the registry. And here we're setting it to the doctor's registry, just to confirm that it has the correct registry, or has a set registry address. All right, let's see if it's come. All right, cool. There's the package we just published to our registry, and it looks very similar to the package we explored earlier, except for now at the bottom it has a deployment, and this is our Save Grandma deployment that lives on the mainnet. And you can see like this is the contract I deployed earlier today. And you know, let's go Save Grandma. All right, so again, we're on the co-ops Web3 instance now. They're connected to the doctor's registry, and right now they're grabbing the package that contains the Save Grandma deployment. This next line, we just grab the contract instance of Save Grandma. Cool, and so like just to get some bearings, Grandma has no ether, the multi-sig contract has no ether, but the co-op has some ether, so we're going to send some money to the multi-sig to fund the multi-sig. Again, another mainnet transaction, so who knows how long this will take. But basically what we're doing here is the co-op has grabbed the Save Grandma instance from the package, and they're just sending some money to the contract deployment, or to the deployed multi-sig. And yeah, so it's, again, this is the Gnosis multi-sig. There are two parties on the multi-sig, the doctor and the co-op, and both of them need to approve a transaction for the transaction to be executed. But of course, if we're sending money, we have to fund the multi-sig first. So cool, looks like that happened. All right, so now the multi-sig has 0.01 ether, which is plenty of money to buy a new prosthetic arm. Okay, this next transaction, now the co-op is submitting the transaction to send money to Grandma. We're basically passing in the Grandma's address, and then how big or how much money we want to send her, and then empty bytes. So this will automatically confirm the transaction from the co-op's point of view. So that's 1 out of 2 confirmations we need to send money to Grandma to execute the transaction in the multi-sig. It will only take a couple more seconds, hopefully. Yeah, so we're approving here sending 0.005 ether to Grandma. So if everything works out well, sooner or later, this Grandma will show 0.005 ether. Cool, it looks like it went through. All right, so now the co-op has approved the transaction to Save Grandma. Now the doctor has to confirm that, yes, it was a shark that bit off her arm, and she deserves this money. So now we're back to our initial Web3 instance, which was the, validated with the doctor's private key. And again, we're setting the registry. I think it's already set, but just doing it again just in case. And then we're grabbing the multi-sig package, which now has a different version than the one we used earlier, and 1.02 is the one that contains the deployment. doctor's instance of the Save Grandma contract. And now the doctor's confirming the transaction that will send money to Grandma. And we just wait for that to mine, and then if this is the second of 2 required approvals, so if this one goes through, it will automatically send money to Grandma, because it tries to, or the Gnosis multisig tries to execute every time a transaction is confirmed. Still going. Cool. So how many people here are hacking this weekend? How many people don't have ideas and are hacking this weekend? All right. Well, that's fine. All these libraries are open source. You can play with them. It went through. So all right, cool. So if everything worked, then Grandma should have some money here. And we can see Grandma has money. The multi-sig's been devalued by the transaction amount. And now she has a sweet new arm. Cool. So I just kind of like talked for a long time and threw a lot of code there. But I hope you recognize that we didn't copy and paste any APIs. We didn't copy and paste any contract code. We interacted only with verified, trusted contract assets. And we accomplished all these goals in not very many lines of code. Especially if I was on the test net, that would have taken half the amount of time. And we saved Grandma. So that was a good accomplishment for everyone here today. If you don't get anything else done, good job. All right, so EthPM, if you're a developer, I hope you kind of see where this is going and how this can be helpful to you. We were using the Gnosis multisig is a fairly simple one or single contract, but EthPM is capable of supporting infinite or much more complex smart contract systems, so you can put as many contracts into a package as you want, and if you package it up well, then you can make any smart contract system available for developers to build on without having to copy contracts, without having to do all the finicky setup that you usually mess up and then you spend 2 hours trying to fix. It's a very easy one-line code to grab any package that you want. Yeah, it makes prototyping very quick and easy for developers. If you need an owned contract for some authorization, you just grab it with one line of code from a trusted registry, install it, and then you're good to go. If you're developing a protocol and you want people to build on your protocol, package up your smart contracts and make them available to developers. A well-created package and good documentation is all a developer needs to start building on top of your protocol with minimal code. If you're a consultant or an auditor or just looking for a job, want to make a name in the space, maintaining a registry with trusted packages is a great way to get recognition in the space. And if you're just a cool person who's into interesting things, this is something good for you. Yeah, I'm here all week. We have a Gitter channel. That's my name. Just ping me if you have any questions or if you want help. I'd love to hear any ideas for contracts you'd like to use. I'll help you package them up. And yeah, I'm gonna. Oh, that's it. Okay, cool. The music has started. Thank you very much. No, just kidding. Here's a really good quote that I like a lot. It helps. I work in a distributed team, working on this amorphous idea that nobody really knows what it is. That is Ethereum. And so yeah, just focus on building good things, and we'll end up building something good together. Thanks.